right?
I think it's liters.
Liters is volume.
See what it says molarity equation? It says moles per liter.
Oh, okay. Yeah, you can do either moles per milliliter or
Yeah, either works, right?
depending on how much stuff you're dealing. So if you're working Coca-Cola,
Yeah.
it'd probably be liters plus, right?
Okay.
If you're dealing in a lab small scale, it'd be moles per milliliter. Yeah, that's a scaling, right?
Okay.
So it'd be moles per milliliter or moles per liter, right? That's my concentration, right? That's my x-axis, right? So now I have how many? How many of these do I have? 5, right? So now I can do my plot, right? So I got 1 data point, 2 data, so it gets clear, a little less clear, a little darker, right? A little more darker, okay? And Rick Ross dark. There you go. Right? These are your data points. This is your standard. Okay? So this is all throughout your laboratory textbook as well as your regular textbook. So now you draw your straight line, right? Like so, right? Okay. Now I can take that standard, I can put it in a computer, you know, do your little engineering, whatever. Now I got a standard, right? And I can make a specific detector to detect a specific thing, right? Okay. So if I can pick up, so now I do that standard, I can get random, like if this little binder has a little bit of copper in it, I can dissolve it. I can put it in the detector that's adjusted to that standard, and it will tell me what the concentration, if any, of copper is in here. That's the way that works. So for example, I take a little bit of metal, I throw it in my solution, dissolve it, put it in my tester, light shines through automatically. Let's say, here was 1 molar, 2 molar, etc., all the way to the end, right? This is an example. Let's say the absorbance fell right here, right? In between these 2 data points. So if you have a certain absorbance, it automatically tells me what my concentration is, automatically. See? Because it's on my what? X-axis, isn't it?
So what is your slope? What would that be?
Great question. Now you develop the plot and the standard. Now you can write your equation now, right? So the equation is going to be Y or A, which is your absorbance. See, absorbance equals the slope's going to be the proportionality constant. That's my Beer's law constant. They call it epsilon. So for this particular system, we call it epsilon. So A equals epsilon, which is my absorptivity constant. I'll write it down here. Absorptivity constant. I think that's spelled that way. Or sensitivity. Absorptivity, right? So epsilon times the what? What's the other variable? Well, the light has to travel a certain distance, right? That would be B, my path length. So B, my path length. And what's my other variable? What's X? Concentration. So sometimes you'll see C, sometimes you'll see M. We'll put molarity, right? So you can put, sometimes some books you'll see M, some books you'll see a C. So we'll put C just to make it clear. Concentration.
It's just absorptivity. B. It's not plus C. Is it C?
Yeah, just C.
Okay.
Epsilon times the path length times the concentration, which is your molarity. And that's Beer's law. Beer's-Lambert law.
See? And you said B was what again? I'm sorry.
Path length. B is path length. See? Right here? The distance here. of your container, that's your path length. The distance a light has to travel. Okay. All right. So that's Beer's law. Absorption equals epsilon absorptivity times path length times concentration. See? Any questions about that? Is that pretty clear? I don't hear one amen. I feel like a poor Baptist preacher. I swear. One amen. You know, lights are flickering on and off. If I don't pay the gas and light bill. It's cold in the wintertime. I got one little gas heater inside of gas. Y'all never grew up like that? People stop coming to church. The choir can't sing. I never told you about that.
They lock you in the church?
Huh?
They lock you in the church and then you pay your tithes?
Oh no, I went to a country church. They don't care.
That's what I'm saying.
That's what I'm saying. That's what they do. That's valid.
Yeah, I remember. I came in the era so I was born in the era in the heyday of everything, where everything was popping, and it was a decline. It was a decline, and it got so bad to where the choir couldn't sing anymore. You know what I'm saying? And so, and the minister was struggling, and I was like one of the only two people in the audience with some other folks. And it was so bad, I started cracking up laughing. I started cracking laughing, so I was like, tears were coming out of my eyes. Oh my God. Even the minister was like, y'all just give up. Oh, your tears just streaming. He's screaming. I thought, oh my God, I don't know what happened. You know? I remember just like 10 years ago, it was packed house, people sweating it, and now it's just like two people that can't sing, and the piano was like two little notes. Ding. Y'all never seen that before? Y'all missing out. It's fun times. Oh yeah. Anyway, y'all had to be there. You would have had to be there. Yeah. I mean, my side was hurting right here. I was like, oh my God.